Good morning, this is John Pendleton with Enertech, and I'll be your trainer today. We're going to cover a little bit of the TXV and reversing valve, their operation, and how to check them, see if they're operating properly. If you have any questions during the webinar, feel free to raise your hand. And it's just me today. There's no, I don't have a little helper today, so it might take me a minute to realize you got a question, but I'll get to those when I'm at a point where I can stop or when I see those. So we'll go ahead and get started. Again, don't hesitate to ask any questions. Today's webinar is recorded. So feel free to check out our YouTube channel, which is Enertech University. And we've got all of our webinars are on there that are recorded, and we upload those there. So definitely check out our YouTube page. All right, let's go ahead and get started. Probably keep you maybe about an hour today. This is me. I'm your trainer, John Pendleton. I've been with Enertech for about 8.5 years now. Background is a service technician, so I did that for at least 20 years and kind of grew up in the industry. So been doing it most of my life. So I'm 46. I've probably been doing it for about 36 years. If you wanted to count the times I worked with my father and didn't get paid. So so I try to bring a little bit of the service side to any kind of training that I do. I think I kind of bring a good mix of knowing what's going on in the field, and I've been there, done that, and wouldn't hesitate to do it again. Here's my contact information, my email, and my direct phone line. The second number listed there is the tech support group line. We'll go ahead and obviously we've already checked to make sure we have water flow by performing pressure and temperature differences. Make sure we got water flow to the unit. Without water flow, we can't diagnose a TXV or a reversing valve. Airflow, if it's a packaged unit, you can usually hear the blower running. Make sure your filter's clean, that kind of thing. On a water-to-water unit, make sure you have load water flow too. Make sure when we're installing water-to-water units that we always put pressure temperature ports on the source and on the load. Makes it a lot easier to diagnose when we have those in the system. We've already checked out the heat of extraction, heat of rejection. Obviously, it's not working out properly. And don't use your refrigerant gauges until you're sure it's a refrigerant issue. Again, water flow, airflow, and heat of extraction, heat of rejection will tell you if you've got an issue on the refrigerant side, on the water side, on the air side, that kind of thing. So it's a sealed system, so we don't want to put our refrigerant gauges on there too much or start pulling refrigerant out every time we put them on there. Sooner or later, it'll get low on refrigerant. So we're going to cover how a TXV works, the causes of a TXV failure, flooding symptoms and diagnosing, starving symptoms, hunting, and restricted. So basically a TXV in heating mode, it's got a sensing bulb, and it's got an equalizer tube with your evaporator pressure. That pressure is there to keep that piston that's right here in the middle on that yellow arrow. It keeps that pressure equalized so the piston can move up and down. So if this tube gets plugged up, it's not going to allow this piston to move up and down properly. So in heating mode, sensing bulb gets warmer, pushes down on the diaphragm expands and pushes down on the piston and opens up the expansion valve to allow more refrigerant flow. You can kind of see the little operation there. If you look at this valve, we've got a spring pressure, we've got evaporator pressure, and we've got bulb pressure. The majority of the time, a valve will stick closed. And that's because this spring here is very thick and big and it's got a lot of power. So if you lose bulb pressure, it's going to slam that piston all the way up. A lot of times when we get this evaporator or this equalizer tube line plugged up, the piston could be stuck midway. So it could just be stuck half open, half closed, however you want to look at it. But whenever we lose bulb pressure, more than likely we're going to have it stuck all the way closed. Very rarely do I see a TXV that's stuck open. So again, heating mode in operation. As conditions change, the evaporator, on the evaporator, the TXV will adjust to try to maintain your superheat. So an increase in suction line temperature increases the bulb pressure, thus opening the valve, allowing more refrigerant to flow. As the evaporator pressure increases, then the temperature gets colder, and it will release some of that bulb pressure, and it closes the valve off. Obviously, we have to have a higher accuracy refrigerant charge when we have a fixed orifice or a cap tube system. And so in a geothermal heat pump, we need to use a expansion valve because we need to adjust fairly quickly to conditions. The most visible indication of proper expansion valve action is suction pressure variation. So if you take the bulb off the suction line and put it in your hand and warm it up, you should open up the valve more and allow more refrigerant to flow. So you'll see your suction pressures, they should move by about 5 to 10 psi. 4 causes of TXV failures. So flooding, so you're feeding too much refrigerant. It's stuck open, which is very rarely seen. We have starving, so it's not feeding enough. It's stuck closed. That's the most likely failure. A lot of times you'll go out there and it looks like the unit's pumping down. And that would be, a stuck closed expansion valve. Hunting, you'll probably see that on your gauges is kind of bouncing around quite a bit. So it's feeding too much, then too little. The reaction is very quick. It's not working in one mode or the other. More than likely, the equalizer tube is plugged. Again, with a bulb loss of charge, we're normally going to send that valve all the way closed because that spring pressure is going to push up. So normally that's the equalizer tube is plugged up and that piston's not allowed to move up or down, so it's stuck somewhere in between. Then we have a restricted, so the TXV is plugged up at the inlet. It could be stuck in any position, but again, it's normally going to stick closed. This is a TXV that's stuck open. So you're going to have a little bit higher superheat, or excuse me, lower superheat and lower subcooling on that. This is a proper charge system. If our refrigerant, you can see here where the blue is, it should be down here by this arrow, and the red should be up more. This would be a properly charged system right here across this yellow line. Symptoms of flooding. So you could have a frosting on the compressor shell. Compressor is noisy, it's got high amp draws, it's running hot. You have low superheat, and you have higher than normal suction pressures. There's kind of some frosting on the compressor, usually on the lower half of it, and then maybe on the suction line as well. Noisy, might be rattling around, doesn't really like it. It may go into internal overload. It's really hard to say, but it will be noisy. You can adjust our TXVs, some of them. I wouldn't necessarily recommend it as they're set at the factory for your proper superheat. If you do have to change it or you do adjust it, remember how many turns you made. So if you need to go back, you certainly can. You can count the number of rotations and go back to the original setting. This is what a scroll should look like. Real smooth, veins in there, no etching, no pitting, no scarring, anything like that. Here's one that's flooded. You can see it's kind of wore some of the paint off there on the inlets. It's kind of roughed up here, and you can see some pitting along the walls. So a starved unit. So on this, we're going to have high superheat and high subcooling. Again, this is the proper charge line. This is your superheat. So we're a little lacking on our refrigerant there. And our subcooling is high as well. Some causes of starving. So you could have moisture or debris in the system. If you just made a repair, make sure you always change your filter dryer and that you're brazing with nitrogen, and never torch out a component. Always cut a component out of the system. Have a restriction on the inlet, clogged strainer. Our TXVs no longer have strainers in them, so we shouldn't really have to worry about that too much. Be low on refrigerant. The pin is stuck in a closed position on the TXV, or the bulb has lost its charge. If you have moisture or debris, it can actually kind of freeze up inside that TXV, and it won't allow it to open properly. So the fix on that is, again, always replace your biflow filter dryer when replacing components. Install a liquid line moisture indicator / sight glass, and that'll tell you if you're getting moisture in it after you've made your repairs. And operate in reverse mode to purge some of the debris. Now it's just going to get stuck. It could get stuck somewhere else, but you can try to work it in the opposite direction, try to break it free, and maybe it'll get caught in the filter dryer. So again, loss of bulb pressure. There's nothing to push down on that spring, so therefore that spring pushes up and closes the valve off. We can change just the head and the sensing bulb on the valve. You can normally take that, you have to back up the body of the valve, and you can use a wrench and take off the head, and you can just replace the bulb head. You can actually take, if you don't know if the bulb is good or not, you take the head off the valve, there's a little disc underneath there, and if you tap on that and that's loose, that means the bulb has lost pressure. It's normally the pressure will seat that disc, so you can't push it. And so if it loses bulb pressure, then it's real loose. You can hear it clicking around in there, and then you know that the head is bad. If you do replace a head under warranty, please let us know that you're just going to change the head. Just to be fair to everyone, it takes about 10 minutes to change the head on the valve, but it takes a couple hours to change the whole valve. So we pay different amounts on labor on that. And so we would prefer that you be honest with us. We're honest with you guys. So we would prefer you be honest with us and just let us know that you're just going to change the head. Hunting symptoms, it could actually be caused by an oversized valve. So maybe you got the wrong expansion valve in the system, or maybe it's for a different refrigerant. Bulb location and contact with pipe, make sure it's insulated as well, so it's reading properly. There could be moisture in the system. Again, if you suspect that, there's ways to try to remedy that. Equalizer tube is plugged or kinked. You're normally going to see fluctuating suction temperatures, so it's going to be kind of bouncing around there, and that's a sign of hunting. Restricted, it depends where the valve is stuck at, but normally you're going to have high superheat and high subcooling. Basically, flash gas is created at the inlet of the TXV, so you can look for either frost or moisture on the liquid line at the TXV. It's basically flashing, and it causes a refrigeration effect right where it's flashing off. And so, if the refrigerant is normally warmed and such, so it's a sure sign of a restriction if it's a colder or there's moisture on that line. I don't see the expansion valves frosting a whole lot, but occasionally we will. Fire and ice test procedure for testing a expansion valve. So run the unit, obviously, I don't care if you're running it heating or cooling. And we're going to remove the sensing bulb from the suction line. Have to remove the insulation and loosen up those copper straps. Pull that off and put it in your hand and warm it up and watch your refrigerant, your suction pressure. Then go ahead and put it in a glass of ice water, and it should drop 5 to 10 psi. You can go back and forth and see if it'll drive. If it is, then you know you don't have a valve problem. If you don't have any change on your suction pressure, the TXV is not responding and it will need to be replaced. Again, check the bulb first, make sure, or check the head of the expansion valve and see that if the bulb has lost its pressure. We do have a TXV troubleshooting video on YouTube as well. You can see that's actually my hand there holding a bulb in the hand, warming it up, and looking at our suction pressure, which is on the left side there. We do have it on YouTube as well. Reversing valve. So you've already checked, again, water flow, airflow, and your heated extraction, heated rejection. We all probably know what a reversing valve does. It switches it from heating to cooling mode. We power our valve, so when it's powered, the unit is in cooling mode. The valve doesn't get or it gets powered, but it doesn't shift. We're going to be stuck in heating mode. So our discharge in heating mode goes through the air coil, back through expansion valve, through the coax, through the suction line on the back from the coax to the suction line on the compressor. In cooling mode, we're discharging to the coax, and then we're going through the coax, through our expansion valve, through the air coil, and back on our suction. It does have a three-way pilot valve on the top of on the body of the valve, and that's what actually gets energized, and then it allows discharge pressure to bleed or be pushed on one end of the bell of the slide on the reversing valve, and then the discharge pressure actually pushes the valve over. The temperature of each line is the way to tell if any refrigerant is bleeding by. So, here in this example, our suction and our loop field coil should be the same temperature, and then the discharge in the tube on the left should be the same temperature. You get about 4 or 5 degree temperature difference in between these, then we know that we're kind of probably bleeding through. So these are your pilot tubes. If you ever really closely looked at a valve, you'll see some really small tubes on the ends and then one on the discharge line. Basically, it bleeds out of the discharge, comes into the solenoid. Depending on where this black slide is, if it's over to the right here, like in this diagram, it's going to push over on this side. Because this pressure here is your discharge pressure, and this pressure here is your suction pressure. So we got more pressure on the left than we do on the right, so it's going to slide that valve over to the right. Once it gets energized, slides that over. Now it bleeds off this higher pressure, and then we're going to have that high discharge pressure on this side, and it's going to slide that valve over. So these pilot tubes get plugged up. The reversing valve won't shift because your pressures won't change. In heating mode, again, the valve is not energized. So that's going to be the path of the refrigerant. Cooling mode, now it's energized, slides over, bleeds off that higher pressure on the discharge. Now your discharge is coming through on the right side, and it's going to slide that valve over. Failed solenoid coil. if you have a O call, which is for the reversing valve, or our cooling call, if it doesn't respond, it will fail safe to heating mode. Obviously, check the electrical operation, go to the lockout board and check between common and O, and make sure you have 24 volts going to the valve itself. You can also ohm out the coil on the valve. If it says OL, then it's open, it'll need to be replaced. Refrigerant leaks. Normally, if we see refrigerant leaks, we see them more on like a water-to-water unit. A lot of times it's because they're running the unit too hard. They've got too much, too high aquastat temperature, and it starts to rattle the unit, a real fine harmonic vibration. And these little pilot tubes will leak, they'll break, they'll snap off. It's kind of hard to see, and it won't really leak a whole lot of refrigerant at one time. And it really is going to depend on what mode it's in, whether type of refrigerant it's going to leak. And so check those. I have seen on these ends, those are pressed in and then soldered shut. And I have seen these little end bells leak as well. The body of the valve, I doubt that it's going to leak, but where these pipes come in, they could leak there, the end bells, or the pilot tubes. If it's sticking and heating or cooling, that could be caused by debris. If you have an acid burnout on a compressor, when you file the warranty on that, you can most certainly ask for a reversing valve. If you think there's going to be a lot of debris in there that could get stuck in that reversing valve. I don't have a problem with it. I'd rather have you change the reversing valve when you change the compressor than install the compressor, run the unit, and realize that you're going to have to change the reversing valve. Now you've just doubled your work. Now, if you got to change the reversing valve, it's going to add 4 more braze connections and about half an hour of time. So it's not as big of a deal. It's a lot cheaper on everybody there. If the valve sticks in mid position, usually the refrigerant pressures will not be equal, but they're going to be close. When they're equalized, that's usually the compressor not pumping. When you're bleeding through, unless you're bleeding 50-50 on all of them, on all 4 lines, then you're not going to get equalized pressure. Normally it's going to be, maybe 150, 175, 130, 175. They're going to look weird to you, and you're going to have low discharge pressure and a little bit higher suction pressure. Again, that could be caused by debris. Maybe the valve's got a defect in it, a big dent or something. I don't know why, but again, they're a little bit more, not quite equal, but look somewhat similar, and you've probably got a problem with your valve. This would be sticking mid position. When it's sticking mid position, it could sound like a scroll compressor running in the wrong direction, and the unit may go out on internal overload. You will be starving the condenser. You can get these little earth magnets from Michael's or Hobby Lobby or something like that. They're little bitty round magnets. You can actually put those on the valve body, and they won't stick to the valve body, but they'll stick to the slide that's underneath that valve body. Valve body's brass, so it's not magnetized. So you can put the little magnets on the ends of that slide here on internally. So this is metal here, this is metal here. So those earth magnets will sense that. You can put 2 earth magnets on it, power that valve up, and see if it slides. And you can kind of watch those magnets to see what kind of travel they have. That inside seals leaking, again, that's going to be bleeding through. And then measure your temperatures. Obviously, your suction and your water coil in this picture should be the same temperature, plus or minus about 3 degrees. And your discharge and your air coil should be about 3 degrees, no more than 3 degrees difference as well. You can tap, or if it won't shift, you can try to tap it. I wouldn't hit it real hard because you can dent the body of the valve, but at the same time, the valve's not working anyway, so what's it matter? You can try to tap it and see if it'll work. Get it to slide. If it does, more than likely it's going to get stuck again, so just replace the valve. If you're in a pinch, sometimes you can get a great big magnet and put it on there and energize the valve, and when you energize it, slide that valve over by hand, and it may slide over. It'll have to be a pretty big magnet, though. Never cut copper pipe with a hacksaw of any sort. I always use tubing cutters. We lose a lot of copper shavings in the pipe when we cut it with a hacksaw. We recommend, if you're going to replace the valve, that you cut it away from the valve so you can, we're not really too worried about you overheating the old valve, getting it out, but it's a lot easier to braise the new valve in if you've got some pipe on the coming out, so you can actually braise the valve outside of the unit rather than trying to do it all in the unit. It's a lot easier to keep it cool. We have what's called a spider kit that you can order on some of our units when you're replacing the reversing valve. We'll have to check with customer service if you've got one, but it'll come with these stubs from the factory brazed on here at the valve itself. And then you can cut anywhere you need to in the field and use some slip couplings, and then you can braze way out here rather than braze at the body of the valve. That's a nice little feature we've added since I've come to Enertech. Is one of my recommendations if we could do that. So we've worked with customer service in the factory and got that available. If you don't have a spider kit, I would recommend marking the lines so that you can line it back up once you get them out. And then you can reinstall those markings and braze it at your truck. And then you can go inside and braze farther away. Make sure you're using a wet rag or some thermal paste of some sort. They've got some spray gel as well, whatever you feel most comfortable with. But there's some Teflon seals in those reversing valves, and you can overheat them pretty quickly. If you're brazing on it, and all of a sudden you see a black puff of smoke come out of one of your tubes, then you've just overheated your seals, and so you don't need to go any further. You need to replace that valve. It's really easy to overheat one of them, especially if you don't have a lot of brazing experience. It just takes time to get comfortable doing it. And, you know, I'm sure most of us has overheated a valve of some sort you know, when we were younger. I know I have. I'm not afraid to admit it. Sometimes the best way to learn is by doing something wrong. So, you know, it just takes practice. Time will get you there, but make sure you always wrap it. I don't care how much time, you know, you've been brazing. It always needs to be kept cool. Again, on a compressor burnout, I am perfectly fine with replacing the reversing valve. On a burnout, we need to do an acid cleanup as well. So if you're not sure how to do that, we have some documents here at Enertech that will assist you in doing that. We would recommend a suction line filter dryer, obviously a liquid line filter dryer. You can replace the reversing valve. If you want to replace the expansion valve, that's fine too. I doubt that's probably going to be the problem, but make sure we're always doing an acid check when you suspect a compressor burnout. So with that, that's all I have for today. Let me get to my contact info here. We don't really need to go through all these questions today. But I have my contact info here for you, so you didn't write it down before. There's my email address. There's also a technical services email address. So if you have a startup form or some pictures you would like us to look at, you can send them to technical services at enertechgeo.com. And that'll go to all of us in tech support. And you can certainly address it to myself or whoever you've been talking to, and we'll make sure it gets to that person. So with that, if there's any questions, feel free to ask. If not, I do have a couple webinars for next week. Feel free to join in those. And then hopefully soon, we'll be starting some in-person trainings. And if you're a distributor or dealer, you want some training, feel free to reach out and we'll get something scheduled up for you. So with that, thanks so much and have a great day.